Alright, there's going to be some rapid fire examples here of how to use this acid flow chart, the equations on the acid flow chart. So what we got here is a 0.045 molar solution of sulfuric acid, and we want to basically find everything about that solution. So basically these four ways to express how acidic or basic it is. And getting started might be the hardest part here, because what we can do is make an assumption, knowing that sulfuric acid is a strong acid. We can assume that 100% of the hydrogens break off. So we can assume that whatever concentration our strong acid is, that is the concentration of our hydronium ion. In fact, this is a weird one. Sulfuric acid is diprotic, so it's actually maybe a little more complicated than that. You might actually get maybe a few more hydronium ions because some of them are going to lose two H pluses. So for the sake of simplicity, I'm going to change the question here. Let's just use hydrobromic acid. And then we can just straight up assume that the concentration of H plus is the concentration given for that acid. And already we've answered this part of the question, the concentration of hydronium. Now the easiest thing to do from here might be to follow the arrow from H plus or H3O plus to pH. And you should see this equation. And that looks like a reasonable answer because this is a strong acid. We would expect it to have a pH significantly lower than 7, and it does. Now let's go the other way and figure out the concentration of hydroxide. So this would be a measurement of basicity. As the hydronium ion concentration increases in a solution, the hydroxide ion concentration goes down. So this is a pretty high concentration of hydronium. We'd expect a very low concentration of hydroxide. And if you follow the arrow from hydronium to hydroxide on your acid equations flowchart, you're going to see something like this. Hydroxide ion concentration is 10 to the negative 14th over hydronium concentration. The product of hydronium and hydroxide is 10 to the negative 14th. So if one of these guys is like 1, the other is 10 to the negative 14th. So H plus here is relatively close to 1, so OH minus should be relatively close to 10 to the negative 14th. And there you have it. And that's the first three things we had to figure out. Now for you Chem 110 students, you can close your ears for a second because I don't think we care about POH in Chem 110, but keep listening Chem 111 students, or sorry, Chem 112. You guys listen too. So the POH, the thing about this is that pH and POH always sum up to be 14. So the POH is 14 minus whatever the pH is. And we found the pH already, right? 1.35. Now, does this answer make sense? A lower pH means more acidic, a lower POH means more basic, so the very high POH means it's more acidic, which is what we know is the case here. So this, I think we're doing well. All right, come back, Chem 110 students. We're going to do another example. For this example, we have a base. And again, this is a strong base. So all of this 0.003 molar KOH plus and OH minus. So we have exactly this concentration of K plus and OH minus. So that solves one part. The hydroxide concentration. But yeah, the key is that you can do this with a strong base or acid. Say that the concentration of hydroxide or hydronium is equal to the concentration of the base or acid when it's strong. And the next thing to figure out might be hydronium concentration. So remember that these two quantities multiply together to get 10 to the negative 14. And this should be on your acid equation flow chart. And yes, when hydronium is high, hydroxide is low, and vice versa. So a high hydroxide should mean a low hydronium, and that's what we get here. And again, pH is the negative log of the hydronium concentration. And always do a reasonability check. This is a base, so we should get a high pH over 7, and that's what we have. And for you Chem 110 students, that concludes this video. For you Chem 112 students, stick around for POH. Your acid equation table loops around, so there's really two ways to get here. What I did was I used the hydroxide ion concentration. I took the negative log of that, and that got me 2.52. And I did it this way because I didn't actually want to plug all this into a calculator for pH. I actually cheated, and I found pH instead of using this equation, which you could have done. I subtracted the POH from 14 to get that number.